In this video, we're going to take a look at rational and radical expressions. We're going to start off by adding to some of the exponent rules we've already reviewed in some previous videos. And this first rule deals with a rational exponent or a fraction exponent. And here we have on the left a to the m over n power, which can be rewritten with a radical as a to the nth root of a to the m. So let me highlight some pieces here. Your denominator piece and your index are the same number. And then I take my numerator, and that is going to be the exponent on my base. Let's look at two very common situations. First of all, let's look at x to the 1/3 power. All right, this can be rewritten as the cube root of x to the first, which is just the same as the cube root of x. And so when I'm trying to convert from what we call a rational exponent to a radical expression, I look at my denominator piece first. That's a 3, so I know the root is a 3rd root. Cube root, 4th root, square root, etc. So that's a pretty common one. Another one that will pop up a bunch is x to the 1/2 power, which would be the square root of x to the first. Okay, and we typically don't write a 2 for a square root. It's understood. And then the 1 on the x is also understood. Okay, so those are very common, and you want to be able to go back and forth between the two. Square root of x is equivalent to x to the 1/2. X to the 1/2 is equivalent to square root of x. All right, what else we got? We have also talked about in previous videos, just want to hit up on it a little bit here, these two rules. When you're multiplying expressions and your bases are the same, x to the a times x to the b, you add your exponents. So for example, x to the 3rd times x to the 5th would be x to the 8th. Okay? And when you're dividing and the bases are the same, you subtract the exponents. So right down here, x to the a divided by x to the b is equal to x to the a minus b. So that may look like something like x to the 7th divided by x to the 2nd. And so that would be x to the 7 minus 2 is 5. All right, so let's look at some examples using some of these rules. And we've got this expression here that we want to simplify. We've got the square root of x to the 3rd plus x all divided by the square root of x. So what would I do first? Well, I would first take all these pieces that have radicals, and I'm going to write them with fraction exponents. So this first term, the square root of x cubed, becomes x to the 3/2 power. Okay, remember there's an understood 2 there because it's a square root, and that's your denominator piece. Plus x all divided by, then I'm going to take the square root of x and write that as x to the 1/2 power. Now, because my denominator has one term, it's just x to the 1/2, I'm going to split up my fraction. And what I mean by that is I'm going to write this as x to the 3/2 over x to the 1/2 plus x over x to the 1/2. All right, now my bases are the same for both terms, and when the bases are the same, we want to subtract the exponents. So let's get some more page. There we go. All right, so our first term, this would be x to the 3/2. I'm going to do that in the margin. Minus 1/2 is 2/2, which is just 1, so we'll just leave it as x, plus my second piece, x to the 1st, so we'll do 1 minus 1/2, which is 1/2. So this is going to be x to the 1/2 power. And I'm not going to leave any fraction exponents, so that means I'm going to write my final answer as x plus, and I'm going to convert x to the 1/2 to the square root of x. And that is my expression simplified. Now, we're also going to talk about undefined expressions. And an undefined expression is when the denominator is equal to 0. Otherwise, the expression is defined. Okay? So let's look at an example here. Here we have the expression 2 over x minus 3. And because it's got a letter piece in the denominator, that's what you want to look for. If it's got a letter piece in the denominator, then it's undefined at some point. That means there's a hole in the graph if we were to graph that. If we were to set it equal to y and graph it. So what number makes that denominator 0? That's all you're asking yourself. What number makes that denominator 0? You can figure that out just by looking at it, or if you want to get technical, you're setting that denominator equal to 0 and solving for x. So it is undefined when x is 3, because if I plug 3 back in, that gives me 2 over 0, or 2 divided by 0, and that makes it undefined because you can't divide by 0. So we would say that this is defined except when x is equal to 3. Let's look at another one. In this example, we have x to the 1/2 power divided by 4 to the x power. Well, when we talk about if an expression is undefined or defined, we're only worried about letters in the denominator piece, okay? So I'm only worried about this 4 to the x situation. Now, this is actually going to be defined for all values of x. For all values of x. Now let me explain why. The reason why it's defined for all values of x is because there is no x value that I can plug in. There's not any single number that I can plug in for x that will give me a 0 in that denominator. Because if I let x equal 0, that would be 4 to the 0, which is 1. 4 to the first, which is 4. 4 to the second, which is 4 times 4, which is 16. So there's no x value that would give me a 0 in that denominator, so this expression is defined for all values of x. And then lastly, this one looks kind of messy. We've got 7x divided by 2 to the 4 minus x minus 8. Okay, so remember when we're talking about if an expression is defined or undefined, we're really only worried about the denominator piece. So here, because I've got a little bit more to it than the last one, remember the last one was just 4 to the x. This one's got a minus 8 tacked on. Let's take that quantity, 2 to the 4 minus x minus 8, and let's set it equal to 0. This way we're finding what x could be to make that denominator 0. Well, we're going to solve this as we would any equation by adding 8 to both sides. 8's cancel. 2 to the 4 minus x equals 0 plus 8, which is 8. Well, I think you guys know that 2 to the 3rd power is 8. So for this exponent to become a 3, that means x must equal 1. That would give me 2 to the 4 minus 1, which is 2 to the 3rd, which is 8. So when x is equal to 1, then this expression is undefined. So another way you may phrase this, we phrased it as defined for all values except on the previous examples, but we could also call this or say all real numbers except x equal 1. So I'm just showing you a couple of ways you might see it expressed when we talk about an expression being undefined. So just keep in mind that when you're talking about an expression being undefined, you're really only focusing on what number will make the denominator equal to 0.